Okay, this is a little video to demonstrate the efficacy of the CTMP 2020 winding and lead resistance compensation. Down here I have a string of 0.05 ohm resistors that I can insert different lead resistance. On the screen right now I have, of course this jumper counts too, but on the screen right now I have the ratio with it clipped right to the binding post. In fact, yeah, that make it. That's right to the right. It's clipped right to the binding post, and you can see that the raw ratio is 1,000.11, and well within tolerance. It's a 0.1% test set. The corrected ratio is fluctuating there because the trig changes kind of rapidly at small angles. The angle is changing like beyond the digits displayed on the screen. Okay, so now the question is, what if you had a CT that was located in a transformer or something? There's a considerable amount of wire between where you had to take the ratio and the CT itself. Okay, let's simulate that. Move it down so I'm adding an extra 0.25 in there, and you can see it's now reading 1,000.58. You know, it's already 0.05% off, so if you're talking about a 0.05% test set, that would be big, but the corrected ratio is still within 1/10 of ratio or so. Once again, it jumps around a little because the trig functions change a lot with small angles at that point, but that is wire resistance, winding resistance, and test lead resistance compensation that gets you to the exact ratio. Thank you for watching. Okay, this is a little demo of the lead and winding resistance correction feature. This is a 600 to 5. It's got a little bit of excitation drop there. You can see it reads 600.38 to 5, but it corrects down to 600 even, just about. So what I'm going to do now is I'm going to take the clip off here and insert it at the end of my string of resistors, and I'm going to add 0.25 ohms of winding resistance. You see the ratio has now gone up to 600.5, but the corrected ratio is still right where it belongs, right around 600 within a few digits. As the angle changes beyond the displayed digits, the trig function changes kind of rapidly, so the corrected angle hunts a little bit, but obviously it's much closer than the raw ratio data. And I put on there, I have a bad clip lead connection, and it's coming back down now. The alligator clip is defective there. And you see when I had that 601, the corrected ratio was still 600 even. Now I'm back to my 600.36. Okay, I've now connected to the 100 to 5 tap. You can see there's a large error due to the relationship between the winding resistance and inductive reactance of the coil. The inductance dropped with n squared, but the resistance, was dropped in proportional to the turn. So the result is you get worse performance as far as ratio error. But the corrected ratio reads 99.96. There's still errors. It's not perfect, but the corrected ratio is a lot closer to the turns ratio than the observed voltage ratio. Thank you for watching. Oh, wait, hold on. Let me introduce a little test lead resistance there and see what happens. Got an extra 0.25 ohms there, and you see it's gone up to 102.97. And the ratio, the corrected ratio, however, still reads 99.94. So I've made the case worse by, adding that 0.25 ohms, and the corrected ratio still reads the turns ratio. Thanks for watching.